When it comes to talking science, I think there are these kinds of things. Again, I'm just going to refer to them, but I think they're all valuable things to help students talk about science. Concept mapping, in that sense. There are these things called discussion of instances, where you show students a particular physical phenomena and say what's going to happen, in this sense. So you can show them a graph, two graphs of what happens to the temperature of water as it's heated. One goes straight up like that, and one's got a couple of plateaus in it. Okay, which do you think is right, and why is that going to happen? Reciprocal reading, where they read to each other. One person reads and the other asks questions, which is a wonderful activity because it forces one person to listen hard, because you can't ask a question unless you have listened hard to it, in that sense. And students need to learn to listen, okay, as you all know, okay, as much as they do to talk, in that sense. And then there are these concept cartoons, which are another version of discussion of instances. In my own line of work, what I'm interested in, I think, very much is opportunities to students to talk about how do we know, okay, where they can engage in some kind of process of argument and discussion. Here's something really simple. Most of it's taught in elementary schools, okay, that day and night are caused by a spinning earth. Okay. Now, okay, another hands-up activity. Okay, if you had a doubting Thomas who came into your classroom, okay, and said, "Miss, I don't believe you. Okay, okay, after all, okay, the sun moves. Okay, it was there in the morning, it's there in the afternoon. Okay, okay, how do you know it was spinning? Okay, okay. Surely, if it was spinning, okay, if we jumped up, okay, we wouldn't land on the same spot. Okay, okay. And thirdly, okay, if the Earth's spinning at the rate they're talking about, it's 25,000 miles here on the equator. I think we're nearly on the equator here in Singapore. Okay. That's over 1,000 miles an hour. Surely we'd be flung off. What would you say to your doubting Thomas? Okay? Okay? How many of you can think the tip of your fingers of a piece of evidence that would convince them of the scientific explanation? I'll give you 30 seconds, okay, which is about as much as you're going to get. Okay? Okay, okay, hands up. How many people reckon they can think of one piece of evidence, okay, that they would use to convince our doubting Thomas? This is a bit worrying. You're all teachers of science, okay? You're supposed to know the answer to this, okay? Okay. All right, maybe somebody can think of two pieces of evidence, okay? Now, well, somebody over there is sticking their hand up, which is nice, okay? I generally find that actually this is so. And it is rather worrying. What it means is that we've all believed it, we've been taught it dogmatically, and either we've all forgotten the evidence for it, okay, or actually we were never shown the evidence for it. And providing students the opportunity to explore and discuss not just why the right answer is right, but in this case why the wrong answer is wrong, okay, leads to a much more secure conceptual understanding of the right answer. Now I know that's very difficult for teachers of science. Okay. My job is to teach them the right answer. You want them to explore the wrong answer? What happens if they go out the door with the wrong answer? Okay. Honestly, believe me, okay, if you give them that opportunity, okay, they don't. Because you make sure that you present them with the evidence. In this case, the evidence, if you've forgotten it, is a first empirical piece of evidence, 1851, the pendulum in the Pantheon in Paris. You often get it in science centres. During the course of the day, the pendulum's plane of movement moves. And it's on a frictionless pivot. So the only explanation is not that there's no force to move it, the ground underneath must be turning. Or this one is the other piece of evidence, in case you've forgotten it. I didn't want you to leave here being worried about what is a standard scientific belief. Okay? This is a photograph of the night sky taken in Australia with the shutter left open over 8 hours. Actually, again, it raises a very interesting scientific point, because there are two explanations for that photograph. Either the camera on the ground is turning, or all of those stars are going round one particular star. We can't decide which. But when we're faced with that problem in science, we introduce a value which is known as Occam's razor, but more commonly today is known as the KISS principle of keep it simple, stupid. Okay? Okay? And keeping it simple is the camera on the ground is turning, and we can all go home, okay? Because we've explained it. But can you see, I think, why that kind of opportunity to explore that in the language of science is quite important? Let me move on to writing. Again, I'm just broadly sketching out stuff that's in the literature that you can read about, I think is important. Types of writing. What kinds of types of writing do you get? Again, this is from research in schools, Year 7, Year 10. Copying or dictated note-taking, Year 7, 46%, 56%. And as somebody once said, copying is a means by which the notes of the lecturer become the notes of the student without going through the mind of either. Okay. Okay. Why is so much of it happening, okay, in science classrooms across the world when there are good textbooks, when they have access to the information? What they need to learn is the ability to distill information, not the ability to copy it in that kind of way. Making notes from printed material, that goes 0 Year 7, 19% in Year 10. Essay or reports of experiments, more in Year 7, less in Year 10, I suspect because they're doing fewer experiments, but they tend to be very formulaic types of writing. And then you get answering worksheets, again, which is a quite significant element of the writing that's going on. Now, all I'm saying is we just need to think a little bit more creatively about the ways in which we can get people to communicate and write science. And people do this kind of thing, and I think are challenging it. It's interesting at Stanford, one of the what you might call odder ways of communicating science that some of the students get into is producing these little rap videos. I don't understand a word of it, okay, but they seem to quite enjoy that process of communication. And I do think we need to think more radically. We also need to think about changing the audience for writing. This, for instance, is the audience for writing commonly you see. For self, do they write for themselves? No. Do they write for a trusted adult? No. Do they write for pupil-teacher dialogue, a kind of interaction between the pupil and teacher? No. Well, 7%. Okay. Who do they write for most of the time? You, okay, the teacher as the examiner. I've got to write this for the teacher because you're going to mark it in that kind of way. There's no pleasure offered in that kind of particular process. Peer group, no. Public, no. And you can change that, okay, simply, if you want to think about it, by thinking about the importance of writing. Anybody here who, in adult life, has to write, understands that actually it's an art, a skill, it needs to be developed, and it's important in science in that sense. Here is Patricia Rao arguing about why it is so important. Okay. It articulates reasons for supporting particular claims and attempts to persuade or convince their audience. They express doubt, ask questions. And these are the kinds of things you want to do. And you have to scaffold the writing. There's a large literature on writing frames, but it's not that complex, I think. But it means giving students particular key phrases. Okay. Here are some of them, for instance. This shows that. Another piece of evidence is. A further point is. I would also argue that. These are common rhetorical devices that we all use in our writing. We all know our own particular bent. But students don't know these. And they need them. And these are words that are quite important. It's also, I think, important that you think about changing the audience. This is some elements of a long list that I have got. Ways of which changing the audience. Okay. Instead of saying, write for me, teacher, okay, write for a friend, write it as a poem. You'd be amazed at some of the things that you get from students, okay, in terms of exploring science. Or as a report in the Straits Times, or an article for the school magazine. Okay. That encourages people writing. They're not just writing for you. You can make some kind of assessment for it, but actually diversifying it makes it engaging. And it's always fun to see the kinds of things that students will produce. This is really quite, I think, an important way of changing the audience.